Hello everyone, welcome to Vedanta JEE English channel. This is your Madhan sir, your big B and physics coach. So, how are you all? Are you good? Hope you people are doing good. I'm doing great. So, let's start the session. If you confirm me that if you people can see me and if you people can hear me, if you type in clear, we'll start the session. So, we will put an end to thermodynamics today. And there is something which is funny, which has been done by the NTA, right? We will talk about that also because they have removed Carnot's engine and all those things, but they have still kept the second law of thermodynamics. And second law of thermodynamics is going to be on heat engines, or one of the statement is going to be giving you information about the refrigerator indirectly. So if those things are removed, then what's the point of giving the second law? That's something which is a bit weird. So we'll superficially do all those things. We will superficially do all those things, and I'm very sorry, man. See, those people who are going to be watching the recording because they have missed the live, we are supposed to have class at 5:30 every week, right? On Tuesday and Wednesday we are supposed to have class at 5:30. By mistake they have scheduled it at 7 today. So at 5:30 I was ready for the class as usual. I've just come, and then when I looked at it, it is 7 p.m. Then I got it changed to 5:45 p.m. I got it changed to 5:45 p.m. Because of that, might be there will be some students who would have missed it. I'm very sorry for that, right? So you can just go through the recording. Okay. So weightage. See, thermodynamics has a lot of weightage in JEE Advanced, and as far as JEE Mains is concerned, you can expect one question from thermodynamics. KTG and thermodynamics put together, you can have one or two questions. One for sure, two if you are going to be lucky. Because the amount of syllabus that is present for present in thermodynamics for JEE Mains is just first law of thermodynamics, man. There is nothing else left. Just first law of thermodynamics. Zeroth law, they can never ask any question on that. What does zeroth law is going to say? I'm not even going to waste a page on it. If A is in thermal equilibrium with B, and if B is also going to be in thermal equilibrium with C, then A and C are going to be in thermal equilibrium. That's what the zeroth law is going to say. Barely you can get any question on that. So the main content is going to be the first law of thermodynamics and different processes and graphical conversions and all those things. So this lecture is going to be talking about different types of processes, some random processes also, right? And then we are going to talk about graphical analysis, and then we are going to be dealing with second law of thermodynamics. As I said, superficially we are going to do that. It's okay, Bhargavan. I think I replied to you in the text, right? I think you were having some doubts and I replied to you on the text. And one more thing, man. If you feel like, feel like talking to me or something like that, then you can comment below the video. You can see if someone is going to ask a doubt, I will be responding. I go through the comments. And the day when I am going to be seeing a lot of good comments, I get a lot of energy. I feel motivated. I feel that, okay, I have taken a right decision from coming from top offline batches. I used to take very good batches in offline, right? Those who produce ranks, like who aim to get a rank below 100, 500 in JEE Advanced. Those are the level of batches I used to take. So from there, coming to YouTube, see, I obviously agree with you, and I accept this fact that on YouTube, you can't give a content which is going to be needed for below 100 or below 500 of JEE Advanced. That level of content you can't give because the majority of the crowd is mostly aiming for JEE Mains, and after that they are going to be aiming for JEE Advanced. Something is burning, man. Or it's my feeling. Is the AC? Okay, might be it's just my feeling. Okay, leave it, huh? I forgot where I was. But whatever it is, my intention was to clarify you this thing that I go through every comment. If you have any doubt, you write it down. I'll reply to that. And in fact, I have recently gone through the old videos also, and I found that someone has asked a question or a doubt on saturation current in photoelectric effect. I have explained it. Then they have said thank you. Also, in that way, I'll just communicate with you people. I have doubt in KTG. I haven't checked today, man. I haven't checked today. I'll be replying back for sure. What will be the duration of this class? The duration of this class is going to be roughly 3 hours. The duration of this class is going to be roughly 3 hours. It got stuck. Just a second. Arey. Come on, man. Okay, there is a crash course which has been launched quite some time back. If you are going to be enrolling in now, you will have the recordings of the old classes. Whatever is going on right now, those you can attend live. Okay, fine. Now look, let us start. Let us start without wasting any time. As suggested by you, I'll use the purple color. Okay. Now, very first thing is going to be, we have to talk about molar heat capacity. So, the very first thing is molar heat capacity. So, it is generally represented with the letter capital C. So, the capital C is going to be the amount of heat you have to give per unit mole, per unit change in temperature is going to be called as molar heat capacity. Now, if I am going to talk about the delta Q, the delta Q is going to be NC delta T, right? So, what is delta Q? The amount of heat you have to supply to the gas to change the temperature of N moles of the gas by delta T, which is having a specific heat capacity, molar heat capacity of C. Now look, when we are going to be going into the chapter, we are going to put a small letter below the C. So that letter is going to give us information. For example, if I am going to talk about delta Q, and if it is written as NCV delta T, this is trying to say that volume is constant. For example, delta Q is NCP delta T is written, then they are trying to indicate that we are following a process where the pressure is constant. If they are going to give delta Q to be some NCX delta T, then we are talking about some X process. In fact, later we are going to call it as polytropic process. I'll introduce what is polytropic process. Whatever is being done is useful for JEE mains, useful for JEE advanced, useful for VIT, BITSAT. Man, all the competitive examinations more or less have the same syllabus. So, Mr. I can't read it. Pulmanicum, right? Like the syllabus is good for all the competitive examinations, everything, including your local CET examinations also. Okay, fine. Now look, we need to talk about internal energy. And we already discussed about internal energy, man. We already discussed about internal energy in the previous class. Internal energy of the gas is going to be represented with the letter U, and for your kind information, the internal energy is going to be F by 2 nRT, where F is the degrees of freedom. Now look, if you talk about the initial internal energy, F by 2 nRT initial. If you talk about the final internal energy, it is F by 2 nRT final. Now, if I am going to talk about change delta U, then it is going to be final internal energy minus initial internal energy, which is going to be F by 2 nR delta T. F by 2 nR delta T. For your kind information, change in internal energy is depending only on the change in temperature, but not how you reach that temperature. What I mean, for example, man, let us take, this is the initial temperature, and somewhere over here we have that final temperature. Look, in order to go from this initial temperature to final temperature, I can go like this, I can go like this, I can go like this. See, in this way, we have infinite number of ways to reach from initial temperature to the final temperature. But when we talk about change in internal energy, is it depending on the process in which we are going? No. So internal energy is state dependent. What is meant by state dependent? We need to know just the temperature at the initial location and temperature at the final location. That's more than enough. We are least bothered about how we reached from T initial to T final to get the change in internal energy. So internal energy is state function, indicating it is independent of path, indicating it is independent of path, indicating it is independent of path. Okay, fine, nice, good. Then what is the other one which is very, very important? When we talk about thermodynamics, we are going to talk about three things: heat, internal energy, and the other one is work. Okay, now let us talk about work. And when I talk about work in physics, we are going to talk about work done by gas. Work done by gas. Work done by gas. Okay, let me just give you one small example. I'll just take a container. In that container, we have gas. We have gas filled in the container. We have gas filled in the container. We have gas filled in the container, right? So that gas is definitely going to have some pressure. So that gas is going to come and apply that pressure on this piston. So how much force this piston is going to experience? Pressure multiplied with the area of the piston. So the force the gas is going to be applying is pressure multiplied with the area of the piston. Okay, fine. Now this piston, let us take that, is going to be moved by very small displacement. That piston is going to move by, let's say, very small displacement, or it is going to have a very small movement, which I am taking as dx. Now look, laptop duplicate, see, VIT is going to be a good option for you in that case. Okay, look everyone. This gas is applying force on the piston, and the piston is going to be moving. Piston will move, and when the piston moves, is this the extra volume the gas has got? As this volume is going to be very small, more or less the pressure changes can be ignored. So roughly, when the piston is moving from here to here, you please take that more or less the pressure to be P on. More or less. Okay. Then if I want to talk about the work done, the small amount of work done by the gas is going to be the force it is applying multiplied with dx. What is the force this one is applying? It is obviously P into A. It's P into A into dx. Okay, now I'll write it like this: P into A into dx. Man, what is A into dx? Look, area of cross section into dx is nothing but this portion or not? Is nothing but this portion or not? So this is nothing but the extra volume the gas has got now. The extra volume the gas has got now, which is nothing but what? The change in volume. So A into dx can be written as dV, which is change in volume, and this is small amount of work which is done by the gas. If I want total work done, then what we have to do? We have to add up all those small work done, right? Now piston is here, it moved here, next it will move here. As the piston keeps moving, the work is done by the gas. We have to add up all the gases, adding up. We have to add up work done by the gas at every step. So adding up is going to be called as what? Integration. Then if you want work done by the gas, work done by the gas is going to be given by integral PdV. Is given by integral PdV. One second. The smell has changed in the room as if something is burnt. No, area of the piston will be given to you, man. Area of the piston will be given to you. You don't need to worry about it. Right? So if it is going to be a circular cross section, they are going to give sometimes radius, or sometimes they'll directly give you the area of the piston. You don't need to worry. No, I got it, man. It's not possible, it seems. You can't switch like that. Okay, fine. Now look, we have to do a lot of research on this part of it. On this part of it, work done by gas integral PdV. Whenever you are going to come across integration, the very first thing that should come to your mind is going to be area. The very first thing that should come to your mind is going to be area. So when I am going to say work done by the gas is going to be integral PdV. Look, this is nothing but what? Area between the curve and v-axis. Never ever forget that. What I mean to say is that, for example, see, look, we have P and V graph, and we have a curve like this. So in that situation, whatever the area is going to be there between the curve with the v-axis, that is going to be called as work done. Sometimes they are going to be testing your conceptual clarity. Man, they'll put P on the x-axis, they'll put V on the y-axis, and they are going to talk about a curve like this. In this situation, as I already mentioned, it is always the area between the curve with the v-axis. Then you have to calculate this area. Be careful. Okay, fine. Now we understood this part. Next, sir, when is the work done by the gas positive, sir? See, in general, P is going to be positive. Now look, the absolute pressure is always going to be positive. If P is positive, for work by gas, to be positive, change in volume should be positive. When the volume change will be positive? Obviously, if volume is increasing. When the volume is increasing. So keep one thing in mind. Work done by the gas is positive only when volume is going to be increasing. That's it. Only when volume is going to be increasing. That's it. Okay. Now look. they are going to make you mug up few things. Let me just talk about a cyclic process. In that cyclic process also, what I'll try to talk about is a perfect circular one. Now I'll just talk about a perfect circular one, but it is not mandatory that always you are going to talk about perfect circular ones only, right? Cyclic process is one such thing where the starting point and the ending point are going to be same. Keep that in mind. Starting point and ending point are going to be same. Now look, if it is a clockwise process, people mug up, man. People mug up. I don't know why. People mug up if it is clockwise positive, if it is anti-clockwise negative, like that, that people mug up. And in chemistry, it is exactly opposite. In chemistry, it is exactly opposite. And look, even if you mug up, if they are going to interchange the axis, then you are going to get wrong answer. That's why in physics, please don't mug up anything. Think logically. In a cyclic process, definitely to a certain extent, volume will increase. After that, definitely volume has to decrease and come back to the original volume, right? So those things you mark separately. For example, if you are going to look from this point to this point, in this entire movement, how the volume is, like what is happening to the volume? Volume is increasing. As the volume is increasing, okay, for that section, you can say this to be the area and this area is positive. This area is positive. Okay, now let me talk about this one. Let me talk about this one from here to here. When I talk about from here to here, what is happening? The volume is decreasing. So when I am going to talk about the area, then I am going to get this as the area between the curve with the v-axis. This is the area. And this work is what? Negative. So if I want the total work done, I need to add that light blue color wala thingy and the red one. As a result, this much positive blue and the negative red are going to get cancelled out, and what you will be left out with? What you people will be left out with? You people will be left out with only this section. Only this section. Right? And what about this one? Obviously, the work here is what? Positive. So one interesting thing which you people have got is, in a cyclic process, area bound by the cyclic process is going to come out to be work. And in this case, it is positive. Okay. Area bound by the cyclic process. Is the work by the gas. Second thing is that, man, if you are going to talk about the area of this, as it is a perfect circle, what will be the area of this one? What will be the area of this one? When I am going to talk about the area of this one, it is going to be pi r square. It's a circle, right? Now look, how do I get that r square? They are going to give you information, man. They are going to give you information. For example, they are going to give this to be V1. They are going to give this to be V2. And they are going to give this to be P1. They are going to give this to be P2. So whatever that area is there, you write it as pi into R. And now look here, diameter. If you look from this side, diameter is V2 minus V1 and radius will be what? Half of the diameter. So 1r you can write it as V2 minus V1 by 2. And now if you look in this way, diameter is what? P2 minus P1. Then what will be the radius? P2 minus P1 by 2. So in a PV graph, if you see a perfect circle, then how you are going to find the area? It is going to be like this. And now what people are going to do? People, I don't know, for some reason, they love to mug up stuff. They are going to be like, sir, as there is a clockwise process, we want the work to be positive. So I'll say that if there is a clockwise cyclic process, work done is positive is what I will remember. No, don't do that. Don't do that. If you are going to be scoring anything around 140, 130 like that, you'll get 90%. I didn't understand, Jayvant. Is it covered all kind of problems? Yes, I am going to cover all kind of problems. How will the volume increase? Sai Tharun, use your visualization. Okay, Mr. Sai Tharun is asking a question. How the volume of the gas is going to be increasing? For example, you have put a piston which is not fixed and you have gas. As you keep heating, what will happen? This pressure is going to push the piston outwards, right? As a result, the volume of the gas is going to increase. Okay, fine. Now look, why I am asking you not to memorize anything is that, look man, go away, yes, went away. So we have V and we have P. Look, I have interchanged. See the very same clockwise thingy again. The very same clockwise thingy again. But I have interchanged the axes. Now you have to be very, very careful. Look, I will mark from this point to this point as 1. So when I am moving from here to here, what is happening to the volume? Volume is decreasing. So the area bound with the V axis is going to be automatically negative. Okay, look, I started here at a greater volume. Now when I have come over here, volume has decreased. Now what I'll do is, obviously as it is a cyclic process, you have to go back to the starting point. So you start here, you move. Now when you are moving from here to here, from smaller volume, you are going to the bigger volume. As a result, the volume is going to be increasing. So this work is going to be what? Positive. So in this case, if you are going to look at the net work done, is the net work done positive or negative? The net work done in this case is negative. Why? Who is dominating? The negative work is dominating. So the net work done is going to be negative. Work done by gas will be negative. Okay. As I said, that's the reason why please don't mug up clockwise, anti-clockwise. Man, Sai Tharun, you have to do the same thing with anti-clockwise. I can't take each and every model and explain, right? You take for anti-clockwise and you see what is happening. Always pick those 2 points. You always pick those 2 points in such a way that between those 2 points, if you go in one way, volume should decrease. In one way, the volume should increase. That's how you have to pick for better clarity. So this is about that cyclic process thingy, right? And work is going to be positive if the volume is going to be expanding, and area between the curve with the V-axis is going to be work done by the gas. Now look, what happens in majority of the cases? In majority of the cases, they give you the process to you. They give the process to you, right? In majority of cases, process process will be given. Process will be given in majority of the cases. For example, they said that it's going in a process where pressure is equal to volume square. Find the work done by the gas. See, work done by the gas is integral PdV. I can put P as V square into dV, which is going to give us V to the power 2 plus 1 by 2 plus 1, and you have to put the limits, which is going to give you V cube by 3, and this is the work done. So in majority of the cases, the process will be mentioned, either a process like this, or they are going to talk about isobaric process or isothermal process, and in all those ways they are going to mention all those things. For example, if they are going to mention, isothermal process, then as they have mentioned the process, look, what we call, as they have mentioned the process, PV is nRT, and this one is constant because we are talking about isothermal. So from here, I can write P as what? nRT by V. And work is going to be what? Integral PdV. Right? So you can put the P value, which is going to be nRT by V dV. And now look, man, as T is a constant, that's why I can take it out. So when I am going to do that, nRT is a constant taken out, then integral dV by V is going to be ln V, and you can put the limits V initial and V final. Then what are you going to get? You are going to get, after substitution, final volume by initial volume. This is what you are going to get, work done by the gas in isothermal process. So like that, generally they are going to mention the process. You don't need to worry about it. No. The pressure is not going to be constant. Pressure relation will be mentioned in the process. For example, if I am going to talk about isobaric process, what is that isobaric process? So you might have a doubt, sir, how to get an isobaric process? How I know that I can maintain a constant pressure, sir? I'll give you an example. Look, everyone. See, let us take that we have a gas. And we have put a piston which is massless. So if I am going to take the mass of this one is going to be 0. Now look, what about the force by the gas, pressure by the gas multiplied with the area? And as this side it is open to atmosphere, what will be the force? P naught into A. Now you tell me, what is the net force on the piston? Net force is going to be mass times the acceleration of the piston. What is mass of the piston? It is 0. Mass of the piston is 0. So net force has to be 0. That means PA minus P naught A should cancel out. Then P is always equal to what? P naught. Now look, when the piston is going to be moving, if the piston is going to move to this side or if the piston is going to move to this side, whatever might be the movement, pressure inside the gas is always equal to the atmospheric pressure. So is the gas undergoing an isobaric process or not, where the pressure is constant? Yes. So if pressure is constant, look, man, when I am going to say work done is integral PdV, P, if mentioned isobaric, then P is constant. Only constants can be taken out of the integral. Look, man, here is the pressure constant? No. As the pressure is equal to V square, as volume changes, pressure is going to change. So I can't take this P out of the integral. If you can't take P out of the integral, in order to do the integration, P should be put in terms of V square. P should be put in terms of V, and we know the relation. We have done that. Right? I can't take P out. Only a constant can be taken out. Same is the case here also. In isothermal process, will the pressure change? Yes. So if I have to get the work done, P should be put in terms of V. P should be put in terms of V. Right? So as we have to put it in terms of V, I have ideal gas equation. Using the ideal gas equation, I have put P as nRT by V. So if the pressure is not going to be constant, somehow we have to manipulate pressure into other terms and put it. If pressure is constant, aram say, man, it's a constant, take it out. So the moment we are going to say it is the isobaric process, pressure is constant. If P is constant, take it out, man. What's the problem? The initial volume, final volume. Then integral dV is going to be V limits Vi, Vf. Then the work done is going to be what? P times final volume minus initial volume, which can be written as P delta V. So work done in isobaric process can be written as P times delta V. Then why are we not considering the sign of work done using the change in pressure? Hey, work done, I already proved it, man. What change in pressure is involved in work done, sir? Look, sir. When I was deriving, change in pressure doesn't matter, change in volume matters. I clearly derived it, Mr. Sai Tarun. So change in pressures are not mattering here. Change in volume matters. So we need pressure at that moment multiplied with the changes in volume. If you do the integration of it, you get work. I clearly proved it. Man, you have to be very attentive, Sai Tarun. You have to keep writing the notes. You have to, it's not that you are going to listen here for 5 minutes, then talk somewhere else and all those things. You have to have proper concentration. Yes, Nikhil, you can. You can. Okay. W is P delta V. Only valid for isobaric process. Now people are going to be like, sir, every time are we going to be given the process? Are we going to have information about the process every time in the question? No. Those are the questions which are going to be good. Not every time. Not every time. Not every time process will be mentioned. Not every time process will be mentioned. Then how are we going to deal with it? Then how are we going to deal with it? I'll just give you one example. I'm just giving you an example of how to deal with those things. Yes, Mr. Nikhil Verma. But if you join bit early, it is going to be an advantage. Let us take for simplicity, just take that it is a massless piston, right? On the left side, we have gas. On the right side, we have atmosphere. And that piston is connected to spring. Is connected to spring also, right? And on the right side, we have atmosphere too. We have atmosphere also. So, nothing is mentioned about the process. Nothing is mentioned about the process. Nothing is mentioned about the process. Then, what we have to do, I'll just tell you. What we have to do is, let us talk about this piston. And let us use work energy theorem to the piston. So, I am observing the piston. And what does work energy theorem say? Work done by all the forces is going to be change in kinetic energy. Change in kinetic energy. If mass is going to be given, then you will understand. If mass is going to be given, you will understand. Don't worry. Don't worry. If mass is going to be given, they are going to say that it is going to be a quasi-static process. That means a very slow moving process. Very slow moving process, then you can take the acceleration to be 0. Then you have to balance out the forces. Then you have to balance out the forces at every instant. Okay, fine. Look everyone. Work by all the forces, right? On the piston, look man, there will be force applied by the gas. There will be force applied by the spring. There will be force which is going to be applied by the atmosphere. Force applied by the atmosphere. Now look, work is being done by the gas. Work is going to be done by the atmosphere. Work is going to be done by the spring. And what is the change in kinetic energy of that piston? Man, the piston doesn't have any kinetic energy. It doesn't have any kinetic energy. So change in kinetic energy. If something is not having any kinetic energy, what is the change in it? Anyway, it's going to be 0. Now look, I don't know what is the work or the pressure of the gas inside the container. But look, it is simply minus of work done by the atmosphere and minus of work done by the spring. And from work power energy chapter, work by spring can be written as what? Work by spring can be written as minus of change in elastic potential energy. Minus of change in elastic potential energy. Because work by spring is a conservative force, work done by conservative forces will be minus of change in potential energy. Now look, without even knowing anything about the pressure of the gas, just by knowing the surroundings, are we able to calculate work done by the gas? Yes, we are able to calculate. If you want to understand this even better, let me just give you one case or a small example. Like I'll give you situation here. See, we have this piston, right? Initially, the spring is in its natural length. And we have gas here. And we have atmosphere here, right? Initially, spring is in its natural length. If piston moves by x, find work done by the gas. Please take this to be massless. Now look, when I am going to talk about this, already in the previous page, I already proved that work by gas is minus of work done by the atmosphere. And look man, minus change in elastic energy. Minus change in elastic energy, which is going to be plus delta U. Delta elastic. Okay, super good. Now, when I am going to talk about work done by the atmosphere, look man, this piston, I am taking that it is going to move to the right side by some x. How is the force by atmosphere? Force by atmosphere will be like this. Because we have atmosphere here, it will apply pressure like this. So the force by atmosphere is like this, displacement is like this. So force by atmosphere is going to be P naught into A, and displacement x, and cos 180. Why did I say cos 180? Because force and displacement are in the opposite direction. Now, change in elastic energy in the spring. So final energy minus initial energy. If it moves by x, spring got compressed by x. And what is the initial elastic energy? It is 0. As a result, you are going to get P naught A into x plus half k x square is the work done by the gas. So if process is not mentioned, then you won't be able to write pressure in terms of volume. Always keep in mind, if process is not mentioned, definitely you have to deal with it in terms of work energy theorem. This is going to be treated bit difficult and JEE advanced from years. There are a lot of PYQs which involve this concept in JEE advanced. Okay, now we have got a proper idea about work, man. Proper idea about work. Now let us go and deal with, sir, what happens to the negative sign? Which negative sign? The negative got cancelled, na? Here minus is there, cos 180 is there, cos 180 is minus 1. Minus into minus 1 is going to be plus. I just skipped one step. Okay, leave. Now, we learned about internal energy. We learned about heat. We learned about work done. Now let us talk about first law of thermodynamics. First law of thermodynamics. I'll put it in a very, very simple and easy way. Take me to be the gas. Right? How humans are going to get energy? We take food. Whatever we take as food, we do some work, rest will be stored in the form of energy. Once again, I am repeating. We take food, right? We get energy. Some energy will spend as work, and rest will be stored in the form of our weight increase, right? If we eat too much, what will happen? Our weight will increase, right? That means our internal energy is increasing. Now, you think of me as gas. What is the food for gas? Heat is the food for gas. So heat is given to the gas. Now what the gas does? It does some work. Rest it will store in the form of internal energy, right? That's what is first law of thermodynamics. Whatever the heat is given to the gas, some of it will be stored in the form of its internal energy. Rest is going to be used as work done by the gas. That's it. See, Vedantu has lower standard channels, Mr. Facts Club. You can enroll over there, or you can subscribe to those channels. This is meant for JEE Mains and JEE Advanced. This channel is meant for JEE Mains and JEE Advanced. Okay, makes sense. Damn good. Now, I already proved that delta U is state function, right? So irrespective of how I move, like which process I take, change in internal energy should be same if the initial temperature and final temperature are going to be two unique things and you are trying to reach in every process the same points. What I mean, for example, see, this is my initial temperature and this is my final temperature. No matter how we reach, irrespective of process, irrespective of process, delta U will be same as starting and ending state, and ending state are same for all processes. Starting point and your ending point. Okay? Clear till here? Now, if that is the case, I'll try to calculate delta U, man. Because once I calculate delta U, it will remain same for every process. That's what I am telling you. So for that, in order to get delta U, this is a problem for me. If somehow I can make the work done by gas to be zero, then I can easily calculate delta U. Okay, to make work zero, I'll go with isochoric process. So I'm using isochoric process to go from T initial temperature to T final temperature. What is the advantage of isochoric process? Volume is constant. If volume is going to be constant, what will be the change in the volume? Zero. Then what is the work done? Work done by the gas is going to be zero because volume is not changing at all. Okay, super good. Now, man, for isochoric process, delta Q can be written as what? Arre? Delta Q is NCV delta T. What about delta U, which I already gave? F by 2 NR delta T. Now look, man, from the first law, we know that delta Q is delta U plus W, delta Q NCV delta T, delta U plus 0. So the delta U is NCV delta T. So although I have got delta U using isochoric process, for your kind information, from this point to this point, if I reach in isochoric process or isobaric process or whatever might be the process, change in internal energy should be same for all of them. So delta U is NCV delta T for all the processes. Sir, come on, sir. You have taken isochoric process, that's why delta Q is written as NCV delta T. If you have taken isobaric process, delta Q would have been NCP delta T, then the delta U formula would have been different. Let us see that also. Let us see that also. If it was isobaric process, agreed, delta Q is NCP delta T. Agreed, man. At any cost, I am completely agreeing with you. And what the first law says? The first law says that delta Q is delta U plus W, and this W is not equal to 0, sir. So this is NCP delta T and delta U, and this is W, which is not equal to 0. When we calculate W and when we subtract W from this one, ultimately delta U comes out to be NCV delta T only, da. So if you choose a different process, then W will exist. If W is going to be existing, I can't directly calculate delta U. That's the reason why I have chosen isochoric process. Hi, Sri Vignesh. You have come back to type that message again. Just pulling you, man. Just pulling you. Just pulling you. Where are you from, Mr. Sri Vignesh? Okay. As I already said, Logically, I already proved. Mathematically also, I already proved. Just because I have taken isochoric process, don't think that delta U is NCV delta T only for isochoric process. It's easy to calculate delta U because W becomes 0. Right? If you have taken isobaric also, it will come out to be this. Now man, as we already know, that delta U is F by 2 times NR delta T. Now let us put what we have got, NCV delta T. Let us put that. NCV delta T, let us put that, is going to be F by 2 NR delta T. Man, delta T gets cancelled out. N gets cancelled out. Then what is the CV? FR by 2. Do you remember in chemistry they'll make you mug up, right? CV for monoatomic 3R by 2, diatomic 5R by 2, polyatomic 6R by 2. They made you mug up, right? This is the reason why. This is how you actually get it. So when you are going to talk about monoatomic, the CV is going to be, obviously degrees of freedom are 3. The previous class we have dealt with degrees of freedom. Now, if I am going to talk about diatomic 1, the CV is going to be 5R by 2. Yes, sir, if you ask me, sir, should we mug these things up? Yes, man, you have to mug these things up. Ultimately, you have to mug them up. Because you can't keep deriving these small things also in the examination. Okay, fine. This is how the CV values are for monatomic, diatomic and polyatomic. Okay, man, super. As we have come till here, is there a way for me to find relation between CP and CV? Okay. Look, when I look at isobaric process, come on, almost we are done with certain amount of theory, right? We'll do some questions. We'll do some questions after this. Okay. Isobaric process, delta Q is delta U plus W. Don't think that this is valid for this. It's universal. First law, valid everywhere for every process. Okay, delta Q, NCP delta T, delta U, NCV delta T. Work done, P times delta V. Isobaric process. In this class only I already did it. For your kind information, when we talk about PV, nRT, pressure is constant. So P into changes in volume is N into changes in temperature when I am going to differentiate. Because P is a constant, so when I am differentiating, dP will be 0. You know, right? When two things are multiplied, first you differentiate the first one, keep the other one as is, then you keep the first one as is and differentiate the second one. Here the differentiation of the first one will be 0 because pressure is constant. Okay, then P delta V can be written as NR delta T. See, using differentiation you can get it, or you can substitute P into V initial is NR T initial, then P into V final is equal to NR T final. Then when you try to calculate P into V final minus V initial, it will come out to be N into R into T final minus T initial. It will come out to be. Okay, sir, put it here. N delta T, N delta T, N delta T. So what is the CP? CP is CV plus R. CP is CV plus R. Ayyo, now for monoatomic. We already know the CV. It's 3R by 2. So what will be the CP? 3R by 2 plus R, which is going to be 5R by 2. We have diatomic. We have the diatomic one. What is the CP for that? See, CV is 5R by 2 plus R, which is going to be 7R by 2. and then polyatomic. Polyatomic. What is the CP? It is going to be 3R plus R, which is going to come out to be how much? 4R. Mine crabs ahead. I already apologized for that. I already apologized. By mistake, they have scheduled it at 7. By mistake, they have scheduled it at 7, man. Sorry. Okay. Okay. We are done with. We are done with isobaric. We are done with isochoric indirectly. Now, what are the processes which are left? Isothermal, adiabatic. These are the 4 famous things. And then we will talk about polytropic process. And then we are going to talk about some random processes which even can't be represented in terms of PV power X. Okay. Now look, if I am going to talk about isothermal process, for your kind information, when I am going to talk about isothermal process, temperature is constant, right? Man, if temperature is constant, internal energy depends only on temperature. Internal energy depends only on temperature. Then how do we do it? Change in internal energy will be 0 because temperature is not changing. Right? See, delta U is always NCV delta T. Right? CV, N are finite values. Finite valued. CV is finite value. So, NCV into 0, which is going to be 0. Now, if I talk about delta Q, it is NCT delta T. For your kind information, the molar heat capacity for isothermal process is infinity, and delta T is what? 0. Infinity into 0 will be what? Indeterminate. So you can't calculate delta Q using this formula in isothermal process. Then what is the only other way? Okay, fine. First of all, let me write the work done also. I already calculated the work done in this class. nRT, ln V final by V initial. So when it comes to isothermal process, writing delta Q as NCT delta T is a dead end because it is infinity into 0. Yes, even graphs are also going to be done. I'm just doing the theory. I'm going to do the graphs also. Don't worry. What does the first law says? The first law is going to say that delta Q is delta U plus W. Delta U is 0. As delta U is 0, it is equal to W is going to be what? nRT ln V final by V initial. What is happening in isothermal process? The entire heat given is getting converted to work. One important thing, the observation is that entire heat supplied. So when I am going to teach you advanced, then I will use this. Entire heat supplied gets converted to work. As Carnot's engine is not there, right, for JEE main, so I won't focus on it, but when for advanced, when I'm going to do it, yes, I will be doing it, and I'll explain why Carnot was smart, why he picked isothermal expansion. See, when it is isothermal expansion, the whole heat gets converted to work, and he is trying to get maximum work from it. That's why. Okay. Now, one small thing, just be there. Adiabatic process, enough of derivations. So what is this adiabatic process? Look, we can take the gas from one situation to other situation by keeping its volume constant, by keeping its pressure constant, by keeping its temperature constant. Those are the things we have discussed till now. Look, I can move the gas in such a way that neither it gives away heat nor absorbs heat. Neither the gas will give away heat nor the gas will absorb the heat. That particular way of movement or that particular process is called adiabatic process. So if you move or if the process is in one particular way, if the pressure and volume are related in one particular way, then you will see that the gas is neither giving away heat nor absorbing heat. Okay, look, delta Q is going to be 0 for this. In that case, delta Q, we know that delta U plus W, see, no matter where the world is going to go, the internal energy doesn't care about it. Change in internal energy is always NCV delta T only. Then work done in adiabatic process is this. So what is that adiabatic process? As I said, if pressure and volume are changed in one particular manner, delta Q will be 0. What is that particular manner? It is PV power gamma is equal to constant, where the gamma is going to be Cp by Cv. So if you are changing the pressure and volume with this kind of relation, yes, the gas is not going to be absorbing heat nor releasing heat. In fact, I can prove this one when I do polytropic process. I'll show you how to prove this. But as of now, Cp can be written as what? Gamma times Cv, right? And we know Cp minus Cv is going to be R. Then gamma times Cv minus Cv is going to be R. Then what is the Cv? R by gamma minus 1. So I can put it over here and I can say work is minus R by gamma minus 1 into delta T. Or I can write work done in the adiabatic process is this. It's up to you. Mostly this is going to be very, very useful for you. If you can remember this, work for polytropic process also can be easily memorized. If work for polytropic process is easily memorized, you'll have lot of advantage. So till now we have done 4 processes, man. Volume constant, pressure constant, temperature constant, heat constant. When I say heat constant, the heat energy associated with the gas is constant. That means it is not taking heat nor giving away heat. Okay. Let us do some questions. A lot of theory has been done and majority of the theory has been covered. From here on, we will be spending a lot of time with questions. Come on. It's done, Chahat. It's already done. Following figure shows 2 processes A and B for a gas. If delta QA and delta QB are the amount of heat absorbed by the system in the two cases, and delta UA and delta UB are changes in internal energy respectively. Man, see, both of them are starting from the same point and ending at the same point. Starting at same point, ending at same point. That means the change in internal energy should be what? Same for both the processes. Because both have same state. Starting state is same, ending state is same. So the change in internal energy for A should be equal to change in internal energy for B. That's for sure. And man, we know that delta Q is delta U plus W. So as delta U is same for both the processes, whichever has more W will have more delta Q. So if you talk about this is the work done in the case of B, and this is work done in the case of A, and clearly as work done in A is more than work done in the B, delta Q in A will be more than delta Q in B. Common sense. So answer will be option 2. Okay. Now do this. Super Tharun. Now do this. A diatomic gas with rigid molecules. Man, why they are trying to say rigid molecules? In the previous class I have explained, when they say rigid molecules, they are expecting you to ignore vibrations. So no vibrational degrees of freedom. No vibrational degrees of freedom. Keep that in mind. A diatomic gas with rigid molecules does 10 joules of work when expanded at constant pressure. What would be the heat energy absorbed by the gas in this process? Okay, let us talk about the solution. Right? See, they are talking about constant pressure process. So work in constant pressure process is P times delta V or NR delta T. And for your kind information, this value is given as 10. Work is given as 10. Okay. Now, they are talking about heat absorbed and the process is constant pressure. So, delta Q is going to be NCP delta T. It's going to be NCP delta T. So, what is the CP value for diatomic? It is going to be 7R by 2 into delta T. So, let me just take 7 by 2 out. Then it is going to be NR delta T. And what is the NR delta T? NR delta T is given as how much? 10. So, it is 7 by 2 into 10, which is going to be how much? 35 joules. 35 joules. Don't know, Harshit. Don't know, man. Don't know when it is going to be. I think those are the last few chapters which are left. Right? Wave optics is left, fluid mechanics is left, and solids and elasticity is left. These are the last chapters which are left. When heat, capital Q, is supplied to a diatomic gas of rigid molecules at constant volume, its temperature increases by delta T. The heat required to produce the same change in temperature at constant pressure. Look down. Is this. So when we talk about constant volume, what about the delta Q? The delta Q can be written as simply NCV delta T, and as it is diatomic one, I can write it as 5R by 2. This thing is Q. Now they are asking to produce the same temperature change under constant pressure process. See, when I am going to say constant pressure, delta Q is NCP delta T. What about the delta Q? I don't know. That is what they asked us to calculate. CP is 7R by 2 into delta T. So you can write 7 times nr delta T divided by 2. So what will happen, man? See, from here I can write q by 5 is going to be nr delta T by 2. Now it is going to be 7q by 5. It's going to be 7q by 5. Revised, Mr. Tarun, just play back the video. You will understand. It's not difficult. Play back the video. For this, you just need to know this one. Work done in isobaric process, you need to know that it is nr delta T. Right? So that is given as 10. I have written it as 10. And delta Q, as it is isobaric process, I'll write it as NCP delta T. Right? Cp for diatomic is 7r by 2. And nr delta T, we already know it to be 10. Okay. Do this 2020. 2020. Starting at temperature 300 Kelvin, 1 mole of an ideal diatomic gas of gamma 1.4 is first compressed adiabatically from V1 to V2, which is V1 by 16. It is then allowed to expand isobarically to volume 2V2. If all the processes are quasi-static, then the final temperature of the gas is. See, why they mentioned the word quasi-static is that they are trying to mention that it is a reversible process. So what is a reversible process? It's a very slow one. So you know what is the pressure and volume at each and every state of the gas. Only then you can plot the graph. See, for example, everyone look, if P and if this is going to be V, if I am plotting a graph like this, man, if you are able to plot a graph, this is definitely a quasi-static and reversible one. Why? Why? Man, you know the pressure at every point and its volume. Can you see that? You know the pressure and volume at every point. You know the pressure and volume at every point. Okay, fine. So that's what the meaning. That means we can use that PV power gamma is equal to constant, that expression. Okay, look, what did they say? First is adiabatic, man. First is adiabatic. First is adiabatic compression. And ultimately what they're talking about, temperature. Man, see, PV power gamma, but we don't need PV power gamma because temperature and volume are related. So you can replace pressure in terms of T and V using ideal gas equation. Then it is going to be T V power minus gamma 1 is going to be constant. So the initial temperature is 300. 300 into V1 to the power 0.4 because gamma is 1.4 is some temperature T2 into what is the volume V1 by 16 to the power 0.4, right? So this is what you are going to get as T2. And then what they are doing, isobarically the volume is doubled. Look, if volume, see, if volume is going to be in isobaric process, volume is going to be directly proportional to temperature. So if volume doubles, temperature also doubles. So the final temperature is going to be 2 times the T2 because from the compression the temperature has become T2 and from there again they have double the volume isobarically, so temperature gets doubled. It's going to be this. So what will be your answer? It is going to be 600 into 16 to the power 0.4. That's it. Mr. KK, just go and wash your face and come. See what is mentioned over here. And Mr. KK, just go and watch. There is a series called Repati Kosam for you. Just go and watch, then comment. Do this. JEE Advanced 2018 question. JEE Advanced 2018 question. One mole of a monoatomic ideal gas undergoes a cyclic process as shown in the figure, where V is the volume and T is the temperature. Which of the following statements below are true? Are true. Okay. In fact, this question I should have given after explaining you the graphs, but still you can manage. Look, man, when we are going to look at this process, temperature is constant. Temperature is constant. As the temperature is constant, we can call it isothermal. Okay. And we have one more here. There also, what is happening? Temperature is constant. So this is also what? Isothermal. Okay. So 2 and 4 for sure we know that they are isothermal. Okay. Now process 1 is isochoric process. It's wrong. That's definitely wrong. And in process 2, gas absorbs heat. In process 2, gas absorbs heat. Look, man, what is happening to the volume? Volume is increasing, right? In isothermal process, delta Q is going to be W, which is going to be N into R into ln final volume by initial volume. So as the volume is increasing, final volume is definitely more than the initial volume. So this is going to be positive. Or you can use your common sense. You can use your common sense. As volume is increasing, work is positive. If work is positive, delta Q is positive. If delta Q is going to be positive, obviously heat is absorbed. So B is correct. In process 2, gas absorbs heat. Now in process 4, gas releases heat. Process 4 is isothermal. Process 4 is isothermal and volume is decreasing. So as volume is decreasing, work done is negative. And we know that in isothermal process, delta Q will be equal to W, which is going to be what? Negative. If delta Q is negative, heat is rejected. Yes, C is correct. Processes 1 and 3 are not isobaric. Okay. They gave T and V information. Now look, if it is going to be isobaric, let us talk about that. If it is going to be isobaric, if the process is going to be isobaric, see, volume should be directly proportional to temperature because P is constant. So you can say V is going to be constant into T. They gave TV, right? So the very same thing, I can write it as T is proportional to V. So T is going to be constant into V. If our brain has to process stuff, better in terms of graphs, whatever is plotted on y-axis, you write it as y. Whatever is plotted on x-axis, you write it as x. So T, you take it as y. C, V, x. So it should be a straight line passing through origin, right? So if you are plotting a graph between T and V, if it is isobaric process, you should get a straight line which is going to be passing through the origin. And do we have straight line here? Do we have straight lines here? No. That means definitely those two processes are not isobaric. So answer is B, C, D. And this is JEE Advanced 2018 question. JEE Advanced 2018 question. Okay. Now, let us talk about polytropic process. Sir, what is this polytropic process? Many of the gases or many of the processes, not gases, many of the processes can be easily represented in this way. And how a polytropic process is going to be represented, I'll show you. So PV power X is equal to constant. PV power X is equal to constant, right? How this single equation is going to have lot of processes in it. Let us see that. Look, if X is equal to 0, then the pressure is constant. If the pressure is going to be constant, can I call this one as isobaric? Next, if X is going to be 1, then P into V is going to be constant. P into V is going to be constant. So can I call it as isothermal? So basically, by choosing proper X values, we can put lot of equations into it. Right? If I am going to take X to be gamma, then PV power gamma is equal to constant, which is what? Adiabatic. If X is going to be infinity, then volume is going to be constant, which is going to be isochoric. This last one, you have to use some common sense to understand it. So directly with this relation, you won't understand. So what you do is, you write it as, okay, 1 second. Let me go step by step again. You'll ask me to explain, that's why. See, PV power X is equal to constant, right? So what I'll do is, I'll do a power of 1 by X on both the sides. Then P 1 by X V is going to be some new constant. Is going to be some new constant, right? Look, if X is infinity, if X is infinity, then P to the power 0 will be there. As a result, V is going to be constant. That is what I have written over here. So the four processes which we were dealing till now are hidden in this or not? Not only these four processes, I have a small question. Is it mandatory that always a gas should be taken in this particular process? Is there any such thumb rule that gas should definitely follow isobaric only, isochoric only, or isothermal only, or adiabatic only? No, there can be any other process, man. There can be any other process. So majority of those processes can be easily represented in this way. So by knowing the final results of this one, it will be very easy for you to solve the questions. It will be very easy for you to solve the questions. Okay. What are those things? Man, whatever might be the process. Whatever might be the process. Delta U is always NCV. Whatever might be the process, delta U is NCV delta T. Right? Hi, Minu. Current electricity is already done by Shreyas or Jayvant. Okay, now look. What about delta Q? Some NCX delta T, because we are talking about polytropic process. Let's take the C to be Cx, indicating X indicating polytropic process. This is where the challenge comes. Work done, integral PdV. Man, when I am using first law of thermodynamics, I have delta Q in terms of delta T. I have delta U in terms of delta T. So my final answer for work also should be in terms of delta T. That means dt should be there. dV should be replaced with dt. Something I have to do, and I have to replace dV with dt. Now I am going to do a derivation. But why am I doing the derivation? For some complicated questions, you should know the approach. That's why I'm doing it. Otherwise, I would have skipped it. Look. As these two are in delta t's, I need this also to be in delta t. To get delta t, I need to have dt. The very first thing is that I have PV power x is equal to constant. Oh, not that. One second. Let me go logically. We know ideal gas equation has PV is equal to nRT. So as T is involved, I can get dt. How to get dt? By differentiation. So you have two multiplied. So first differentiate pressure, keep this, and then you keep P as it is, differentiate V is going to be nR dt. Ayyo, we have a problem. If I am trying to replace PdV will be what? nR dt minus dPV. I don't want any dPs, dVs, man. I want everything in terms of dt. So this equation alone is not sufficient. This equation, think about, see, it is all important for you to just analyze how a teacher is thinking. I have reached this step. My aim was to get dTs. To get dt, I can write PdV as nR dt, but I have a problem. This dPV is going to come this side, then I'll have dP terms. I should not have any dPs nor dVs. No other go. They have given a process for us, so we have to take help of the process. So we have PV power x is equal to constant. So differentiate this one. So dP into V power x plus P into x V power x minus 1 into dV is going to be equal to what? 0. Differentiation. So V power x minus 1, you can take common and it goes to that side. When you do that, dP into V plus xp dV is going to be 0. So I can write dP into V as what? Minus xp dV. That's it, man. Put it into this, and from here it is minus xp dV plus pdV is nR dt. Look, what is the pdV then? The pdV is nR dt by 1 minus x. Success. N is a constant, R is a constant, 1 minus x is a constant. Right? Vijay, sorry man, by mistake they have scheduled it at 7, but actually it was supposed to be started at 5:30. By mistake, sorry for that. Not mistake from my side, from their side. Okay, go here. Then W will be what? See, although some people will be finding it difficult by now, but the reason why I am doing this, as I said, when you go for some tough questions, you need this approach. Definitely you will be in need of this approach. Keep that in mind. Okay. Now, sir, easy, sir. Constant is taken out, sir. dt can be written as t, sir. Then work is going to be n into r by 1 minus x into t initial, t final. Come on, man. I'll write work as nr delta t by 1 minus x. That's it. Mug this one up. At any cost, mug this one up. Very, 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 very important. Okay. Now what I am going to give is a direct question in many examination. Direct question in many examination. Okay. First law of thermodynamics claims that delta Q is delta U plus W. What is delta Q? NCX delta T. What is delta U? NCV delta T. What is W? NR delta T by 1 minus X. So N delta T, N delta T, N delta T got cancelled out. So the Cx is Cv plus R by 1 minus X. Man, they gave some random processes. They gave some random processes and they asked the molar heat capacity for that process. So this is too important. Is very, 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 very important. Now, do you know, from this only we can prove adiabatic process. What is adiabatic process? A process where delta Q is 0. So temperature changes can take place, but in order to increase the temperature of the gas, you don't need to supply any heat, right? So when I am going to say adiabatic process, what is delta Q? 0. That means what should be the C value for that process? 0. So put the C value as 0. It will be Cv plus R by 1 minus X. So it is going to be Cv into X minus 1 into R. Man, it is going to be Cv into X plus Cv plus R, which can be written as what? Cp. So what is the X value? Cp by Cv. That's how, man, that's how they found out. They actually derived it like this. So if the X is Cp by Cv, then the molar heat capacity for that particular process is 0. So let me write it. If we have PV Cp by Cv is equal to constant, then for this particular process, C is 0, molar specific heat is 0. That means delta Q is 0, as it is big to write. That's why they represented with this symbol. Now did you understand, everyone, how gamma is Cp by Cv? How gamma is Cp by Cv? Is everyone clear? It is a part of polytropic process. So in polytropic process, we are going to calculate the Cx, which is going to be the molar heat capacity for that process. So if you want delta Q to be 0, then C to be 0. If you put C to be 0, then the X should be Cp by Cv. Thank you, Mino. And it is always good. See, I'll be honest. Even you people also. If a teacher's classes are available for all the chapters, you stick to one teacher. Even though the teacher is going to be, let's say, teacher is good, very nice, all you can listen from him only. Teacher is mediocre. Even then, if all the lectures of one teacher is going to be available, you better follow him. The class is going to be roughly 3 hours. Roughly 3 hours. Vijay, I hope everyone understood. Randomly, people didn't wake up and say that gamma is Cp by Cv. Actually, if the ratio, that is, if the Cp by Cv is going to be the power of PV, power, then C is 0, then delta Q is 0. Writing like this is going to be tiresome. That's why people have introduced a new letter called gamma. That's it. Sai Kumar, nothing can be done. See, always keep one thing in mind. Things, whatever are there in our hand, we should worry about them. Things which are not there in our hand, don't worry about them because you can't do anything. When the NTA is going to set some rules, or if the JEE Advanced IITs are going to set some rules, we can't do anything. Don't feel sad or bad for those things. Dunda, dunda, dunda. I would love to give you some questions. Look, They have given PV square is equal to constant, right? And they are asking find the molar heat capacity for this process. Find the molar heat capacity for this process. Minu, I didn't understand. What doubt you have? You said, sir, I follow your classes only, right? I can't see any doubt in that. Or might be you have put your doubt way above, right? As the chat is getting got spammed, so you better put your doubt again. Look, in all these processes, we have to use this formula: CV by 1 minus x. Okay. What is your question, Mr. Minu? To answer, I need to know the question, na? Okay, fine. Look, so PV power x is equal to constant. So when you compare these two, from here x is going to be what? 2. Then the Cp is going to be Cv plus R by 1 minus 2. Where the Cp value is going to be Cv minus R. Not Cp, my bad. Not Cp. Not Cp. It's a C for that process. C for that process. My bad. C for that process. How can we use differentiation in problems? I didn't get you the... Whenever they are talking about changes, change in volume, change in pressure, change in temperature, differentiation is also what? Changes, but small changes. So whenever you see changes, then you have to use differentiation. For example, let us say work done is going to be PdV. You see dV. dV is differentiation thingy, right? Differentiation of the volume. So whenever you see dVs, dTs, how you get dVs, dTs? Obviously by differentiation only. Okay. I would like to go slightly deeper, but on mains level, I don't think it is needed. Okay, leave that. Some random processes. It's not mandated that every time you should come across polytropic only. PV power x is equal to constant. Right? So I have taken some random process. See, they said that 1 mole of an ideal gas passes through a process where the pressure and volume obey the relation like this. So if you look at this one, you can't write it as PV power x is equal to constant. Right? You can write it as PV power x is equal to constant. So not everything can be written as PV power x is equal to constant. So here P0 and V0 are constants. Calculate the change in temperature of the gas if its volume changes from V0 to 2V0. The very first thing which you have to look at is they are talking about changes in volume. And they are talking about change in temperature. Here pressure and volume relation is given and they clearly mentioned that it is an ideal gas and it is 1 mole. So this relation should be converted to T and V relation. Should be converted to T and V relation. Okay, now look. PV is equal to nRT is the ideal gas equation. And they are talking about 1. They are talking about 1 mole. So I got this to be the pressure. And what is given? What is given? P is given as P naught into 1 minus half V naught by V square. What's the P? RT by V is P naught into 1 minus half V naught by V square. So from here, I just need a T. T is going to be P naught V by R. T is going to be P naught V by R into 1 minus half V naught by V square, right? So what is the initial temperature? Initial temperature, right? You take it to be like volume V naught, right? Put it as V naught. So it is going to be P naught V naught by R into 1 minus half V naught. V should be put as V naught. Then it is going to become 1. As a result, you will get it to be P naught V naught by 2R. T final. You have to put the volume as 2V naught. Then P naught into 2V naught divided by R into 1 minus half. What are you going to get? V naught by V, right? But what is the V? 2V naught. So V naught by 2V naught, which will be half square. So 1 by 2 into 1 by 2 square will be what? 1 by 4. 1 by 2 into 1 by 2 into 1 by 4, 1 by 8. So you are going to get 7 by 8. So which is going to be 7 P naught V naught by 4R. Now, if I am going to talk about the change in temperature, what they have asked, it is T final minus T initial, which is going to be what? 7 P naught V naught by 4R minus P naught V naught by 2R. So you multiply with the 2 and divide with the 2. As a result, you get 5 P naught V naught by 4R as your answer. As your answer. 5 P naught V naught by 4R. Thank you, Mr. Pradeep Chand. Thank you. Where are you from, Mr. Pradeep Chand? Meanwhile, other people do this question. Thank you, Mr. Manish. I think you can write JEE mains, but you won't get admission into IITs, I think. The percentage I don't remember for IIT, man. 60 or 75, I don't remember. I have to check. During the counseling, it will be a problem for you. I think Shreyas sir did a video on that, right? Mr. Sai Kumar. They are good with all this kind of data. I am good with subject. All I know is physics, that's it. Even if someone is trying to feed me data, a minimum criteria 60, 50, 40, whatever, it just goes out of my mind. Do you know, even till date, after being a teacher also, every day when I am going to go to bed, I will pick a question, right, which I haven't got. I'll keep thinking about it and I'll go to sleep. That's how I am. Sir, at the end of the session, can I ask you some questions related to preparation? You can ask Mr. Vijay, I'll answer. Jai Akash. Sir, how many questions can we expect from this chapter? JEE Advanced, you can expect in both the papers together on an average 3 questions. 2 to 3 questions, pakka. On an average, all the years put together. Okay. The equation of state for a gas is given by PV is equal to nRT plus alpha V, where n is the number of moles and alpha is a positive constant. The initial temperature and pressure of 1 mole of gas contained in a cylinder are T0 and P0 respectively. The work done by the gas when its temperature doubles isobarically. This is not an ideal gas. Although in physics, 90%, not 90, 95% of the times we will talk about ideal gases, but sometimes we won't come across ideal gases, we will come across real gases. Okay, now this is a real gas, or at least it's not an ideal gas. It's not PV is equal to another, it is something else. But man, when I talk about work done by gas, it is always this. And if it is an isobaric process, it is always this. Because pressure is constant, you can take it out. Integral dV is going to leave you delta V, which is change in volume. So my aim is to calculate this change in volume. And do we have a relation? Yes, we have a relation. PV is nRT plus alpha V. Okay, what are they talking about? They are doubling the temperature isobarically, and that pressure is P naught. T naught is the initial temperature. So P naught, initial volume, into nR T naught alpha initial volume. So from here, can you tell me what will be the initial volume? The initial volume into 1 minus alpha is going to be nR into my bad calculation mistake. P naught minus alpha is nR T naught. So the initial volume is this. And then what are they doing? They clearly said that work done by the gas when its temperature doubles. Temperature has doubled, it seems. If temperature has doubled, so from here I can write the final volume to be N into R into final temperature, which is 2T naught divided by P naught minus alpha. That's it, man. From here you can manage. What is the work done? It's P naught into final volume minus the initial volume. Initial volume is written, final volume is written, you can manage it. And don't worry about N. Sir, there is N. And in the options, we don't see N. For your kind information, they gave it to be 1 mole. For your kind information, they gave it to be 1 mole. Now, after this, I would love, okay, 1 second. What will be the answer then? You will get it to be P naught R T naught by P naught minus alpha, which will be this. This is the answer. Option 1 is the answer. Now look, I'm giving you one additional point. As sometimes in physics, they are giving these kind of things, these real gases. So I have seen some situations where they are going to talk about the C value for a real gas. 1 second. Just have an idea about this. Just know this one. For ideal gas, C, what is C? Molar heat capacity doesn't change with temperature. So basically, if I am going to plot for ideal gas, C versus T, it will remain to be constant. As temperature changes, C is not going to change. But for real gases, C, molar heat capacity is going to change with the temperature. The C value is going to be changing with the temperature. Sir, if the C value is continuously changing, sir, then how do we calculate the C value? How do we calculate that C value? That becomes a good question, which is close to advanced level. which is close to advanced level. Look, whenever you have to find in these situations, please use dq is equal to du plus dw. dq is equal to du plus dw. What is dq? ncx dt. What is du? ncv dt. What is dw? pdv. But convert this to dt. How to do the conversion? Do you remember when I was doing the polytropic process, I said to you purposefully I am doing the derivation in order to show you how to deal with the things. In order to show you how to deal with the things. Where is polytropic process? Let me go back. Look, man, we have PdV, but our aim is to convert it to dt. To convert it to dt, can you see the process? So you have to do this process. If you are going to be doing that process, then successfully you can convert PdV to dt terms. Then n dt gets cancelled out. You get the C for the process. This is how you have to do. But yes, when questions are going to come on this, people find it tough. People find it bit tough. Yes, Mr. Sujit, 11th standard kids can see because thermodynamics is in 11th. Now, man, I have to start the graphical analysis. Before I start the graphical analysis, I would like to give you some 10 minutes of break. Even I'll drink some water and come. Right, it's 7:41, right? Break of 10 minutes. I'll be back at 7:51 p.m. 7:51 p.m. I'll be back. Right, you people also, please wash your face and be ready. Please wash your face and be ready. Right, the graphical analysis, I'm going to talk about slope and all those things. So please be ready. Okay. Okay, I'm back. See, mostly the graphical analysis, we should have proper understanding between isothermal and adiabatic. That's the major part where a lot of questions are going to come. So it is always going to be the comparison between isothermal and adiabatic one. So it is always going to be comparison between isothermal and adiabatic majority of the times, right? So on the left side I'm going to talk about isothermal, and the right side I'll talk about adiabatic. We can identify them with the help of slopes. If we are plotting a graph between P and V, with the help of the slopes, we can identify which graph belongs to what. For example, when I am going to say PV is equal to constant, so I will differentiate, because when I am going to talk about slope is going to be coming from differentiation only. Na? What is dy by dx? Rate of change of y coordinate with respect to x coordinate, which is nothing but slope. Alright, can you people hear me and see me? If you people can hear me and see me, type in clear. So dp into v plus p into dv is going to give us 0, because differentiation of a constant is going to be 0. So now my aim is to calculate dp by dv, because dp by dv is slope of PV graph. Which is going to be what? Minus P by V. Okay. Now, when I talk about adiabatic process, it is PV power gamma is equal to constant. So when I am going to talk about the slope, obviously, dp into V power gamma plus P into gamma V power gamma minus 1 into dV is going to be 0. So when I do the math, dp by dv is going to come out to be minus gamma times P by V. So which has more negative slope? Obviously, adiabatic process has more negative slope. Adiabatic process has more negative slope. See, more negative slope. First of all, negative slope indicates what? If volume increases, pressure should decrease. That's what is negative slope. If volume decreases, pressure should increase. So if one is increasing, other should decrease. Negative slope indicates if one increases, other is going to be decreasing. If one increases, other is going to be decreasing. That's what is meant by the negative slope. Now, who has more negative slope? Adiabatic process. So, for example, for a given change in volume, more change in pressure happens in adiabatic process, because it has more negative slope. Okay, now look, let us try to apply that. For example, man, I'll go step by step. Take this to be P, take this to be V. Look, I am marking two graphs. One is isothermal, one is adiabatic. You tell me which one belongs to what, like which one is going to be isothermal, which is one is going to be adiabatic. This you take it to be 1, this you take it to be 2. So 1 belongs to which one, 2 belongs to which one? 1 belongs to which one and 2 belongs to which one? As I said, for all these type of things, I would suggest you to go for a comparison. I would suggest you to go for a comparison. So we have certain change in volume. For the same change in volume, who is going to have more change in pressure? Let us look at this. Let us look at this. So for the first graph, this much is the change in pressure. And for the second graph, this much is the change in pressure. Whoever is going to be having more changes in pressure for same changes in the volume is going to be adiabatic process. Look, we have increased the volume and there is more decrease in pressure for the second graph. So that's why this is going to be adiabatic. Then automatically this is going to be isothermal. Isothermal. Now look, let us talk about this one. Let us talk about this one. So I'll talk about same changes in volume. I'll talk about same changes in volume. When I talk about same changes in volume, look man, the below graph has this much change in pressure and the above graph has this much change in pressure. So who is having more changes in pressure for same change in volume? Graph 2. More changes in pressure should come for adiabatic for same changes in volume. So graph 2 is going to be adiabatic and graph 1 is going to be isothermal. So there are some people who are going to mug it up. Always they'll think that top graph should be isothermal. Look here. Top graph is what? Adiabatic. Here what is the top graph? Isothermal. So when there is an expansion, there is more work in isothermal process. And when there is a compression, there is less amount of negative work in the isothermal process. Again, keep this in mind. I'm going to use this when I'm going to do Carnot's engine, when I'm going to be doing it for advanced level. Right? Okay. Now, few more observations. Look, see, we know that gamma for monoatomic is 5 by 3, which is 1.66. Diatomic 1.4. Polyatomic 1.33. So we know that gamma for monoatomic is more than gamma for diatomic is more for gamma of polyatomic. We know this sequence. Now I would like to give you one question. That question is, let us say we have P and V and we have 4 graphs. Out of the 4 graphs, 3 are adiabatic and 1 is isothermal. 3 are adiabatic, 1 is isothermal, right? Out of those 3 adiabatic processes, we have 3 different gases are monoatomic, diatomic and polyatomic. So which one is monoatomic adiabatic? Which one is polyatomic adiabatic? Which one is diatomic adiabatic? And which one is isothermal? Which one is isothermal? So 4 of them are there and I am expecting you to answer that. So now if we are going to talk about, look, just mark them. Look, you have least changes in pressure for the top graph and then the least is for the next graph and then the next one and then this one. So highest is for this. So the bottommost graph has highest change in pressure. highest change in pressure is going to result in highest negative slope. Highest negative slope is going to be for highest gamma 1, and highest gamma 1 is what? Monoatomic. So this is monoatomic gas and undergoing adiabatic. Monoatomic, adiabatic. Then diatomic, adiabatic. Then polyatomic, adiabatic. Then the last and the least changes are for isothermal. So majority of your conceptual understanding and conceptual knowledge will be tested with isothermal and adiabatic ones. Isothermal and adiabatic ones. Okay, let us take some questions. Do this. Do this. The given diagram shows 4 processes, that is isochoric, isobaric, isothermal and adiabatic. The correct assignment of the processes in the same order is given by. So first one should be isochoric, man. Isochoric means volume should be constant. Isochoric, volume should be constant. That means first should be D. How many options have D as starting? We have this as D starting, we have this as D starting. And then if you look at DA, now let us talk about the third one. Because here the third one is C, here the third one is B. Let us talk about that. Isothermal, third is isothermal. Now you can clearly see that who is going to be having less changes. Who is going to be having less changes in pressure for same change in volume. For same change in volume, there is more change in pressure for more change in pressure is there for C. So C is going to be adiabatic, B is going to be isothermal. Isothermal. Okay, then isothermal is what? B. So which answer? Option 4. Option 4 is correct. Okay. Do this question also. It's a conversion. It's a conversion question. It is a conversion question. Come on. A cyclic process is shown on the VT diagram. The same process on the PT diagram is shown as. Man, when these type of diagrams are going to be given, you just pick any one of the paths and eliminate the options. You see how I am going to be solving it. Look, I can see that B to C, the temperature is constant. Let us go for the graph and see how many graphs have B to C temperature constant. Temperature is constant, B to C. No, temperature is not constant, B to C. Temperature is not constant, B to C. Temperature is constant. So now, if I see in this B to C, pressure is decreasing. Here, pressure is increasing. So if I can find out whether pressure is going to decrease or increase, then I'll get the answer. Here, temperature is constant, volume is increasing. We know PV is nRT. So if temperature is going to be kept constant, if the volume is going to be increasing, pressure has to decrease. So I should pick a graph where pressure is going to be decreasing. Here pressure is increasing, here pressure is decreasing. So I should mark option A. I should mark option A. Okay. Next. Do this. Do this graph. Do this graph. And after this, I have taken one JEE advanced question. A thermodynamic cycle X, Y, Z, X is shown in the VT diagram. Okay. The PV diagram that best describes this cycle is, okay, man, Y to Z volume is constant. Let us see, Y to Z volume should be constant. Wrong. Y to Z volume should be constant, Here volume is changing. Y to Z volume should be constant. Wrong. Y to Z volume is constant. Y to Z volume is constant. But now we have to see whether pressure will be like what is going to happen to the pressure. Cycle is also going to be important, right? Here up arrow is there, there down arrow is there. Now look, when I am going to go from Y to Z, see volume is constant, but temperature is decreasing. We know that PV is nRT. See, if volume is going to be constant, pressure is directly proportional to temperature. So as temperature decreases, as this one is decreasing, so pressure should also decrease. So when you move from Y to Z, pressure should decrease. When you move from Y to Z, pressure is increasing. When you move from Y to Z, pressure is decreasing. So which option? Option 4. Vijay, I will be taking. Don't worry. This is the JEE Advanced 2018 question. Man, this last option is not that visible for you. The last option is not that visible for you. It is work done by the gases. Work done by the gas. Now it is visible. Now it is visible. So this is JEE Advanced 2018 question. 1 mole of a monoatomic ideal gas undergoes 4 thermodynamic processes as shown schematically in the PV diagram below. Okay. Among these 4 processes, one is isobaric, one is isochoric, one is isothermal, one is adiabatic. Wow, wow, wow. Super. Okay. Match the processes mentioned in list 1 to the corresponding statements in list 2. In process 1, where is process 1? Oh, we have process 1 here and we have process 2 here, and they are starting at same point, like, or you can say they are ending at same point. So if this is the case, then this one is going to be isothermal and this one is going to be adiabatic. You can see if they start at same point here, then the top one is going to be isothermal, bottom one is going to be adiabatic. Okay, I realized that process 1 is adiabatic. If process 1 is adiabatic, no heat will be exchanged. No heat will be exchanged. Okay, fine. Now, in process 2 is isobaric, pressure is constant, right? If pressure is going to be constant, what will be the work done? Work done in isobaric process. Work done in isobaric process is pressure multiplied with change in volume. What is the pressure? 3V naught. What is the change in volume? It started here at V naught volume. What is the volume it went to? It went to 3V naught. So 3V naught minus V naught is going to be 2V naught, which is going to give 6P naught V naught. 6P naught V naught. Okay. Next, process 3. Process 3 has constant volume, man. If constant volume is there won't be any work done. So this. And then process 4. Process 4 is isothermal. So temperature is going to remain constant. Done. This is JEE Advanced 2018 question. Okay. Now the equivalent CPs and equivalent CVs for the mixtures. Equivalent CPs and equivalent CVs for the mixtures. Okay. First, I'll talk about CV. And is it mandatory that in the container you should always have same type of gas? No, right? There can be different gases. For example, we have one gas which is like this, and this gas has some N1 moles. This one has some N1 moles. And I have one more gas which is, let's say, diatomic. and let us say some N2 moles of it is there, like that there are many types of gases, man. There are many types of gases. Now, I don't like, I don't like, I don't like, to be frank, this. I don't like the container having different types of gases. So now I want to replace all those gas molecules with a single type of gas. But I should not change the quantity. So I should not change the number of moles. I want to replace it with one type of gas. I want to talk about replace it with one type of gas. And the number of moles of this one should be taken as what? N1 plus N2. Number of moles, that means the quantity should not change. But different gases should be replaced with one. So what is the CV equivalent of this gas, which is equivalent to this combination of gaseous mixture? What is the CP equivalent of this, which is equivalent to this gas? Now look, man, if I want CV equivalent, look, I'll talk about constant volume. Because I am in need of what? CV terms. So how much heat I have to give to N1 moles to change its temperature by delta T means dQ1, or you can say delta Q1 is going to be obviously N1 CV1 delta T. How much you have to give to the second gas to change its temperature by delta T? This much. So what is the total heat you are providing? So the total heat you are providing to change the temperature of the gaseous mixture by delta T is N1 CV1 plus N2 CV2 into delta T. That much heat you are providing to this whole container. If the same amount of heat is given to this one, if I say this gas is equivalent to this gas, then this gas temperature should also change by the same amount. So if I give the same delta Q to this, then this one should also be changing its temperature by delta T. Put it over here, then the CV equivalent will come out to be N1 CV1 plus N2 CV2 divided by N1 plus N2. So this is how you get the CV equivalent by taking constant volume or isobaric process. But if they are going to talk about CP equivalent, you take isobaric process, then you will get N1 CP1, N2 CP2. So when you repeat the same process but with P's, then you get the CP equivalent. So in the same way, if you do it in the same way, what will be the CP equivalent you are going to get? It is going to be N1 CP1 plus N2 CP2 divided by N1 plus N2. Okay. If they ask gamma equivalent, gamma equivalent is the CP equivalent you have got by the CV equivalent. That's it. So when you are going to do that, see, both of them have N1 plus N2 in the denominator, so they get cancelled out. It's going to be N1 CP1 plus N2 CP2 divided by N1 CV1 plus N2 CV2. You do this, you get the answer. And gamma for the mixtures, CP equivalent, CV equivalent are bit frequent, man. Do this. 2 moles of an ideal gas with Cp by Cv is equal to 5 by 3 are mixed with 3 moles of another ideal gas with Cp by Cv 4 by 3. Man, what is happening over there? 4 by 3 is going to be polytropic, sorry, polyatomic. This one is monoatomic. So they have said 2 moles, write it as 2. Okay. The value of Cp by Cv for this mixture is going to be, so the gamma equivalent is going to be N1 Cp1 plus N2 Cp2 divided by N1 Cv1 plus N2 Cv2. So for this first one, it is 2 into 5R by 2 plus 3 into Cp for this is 4R 3R 4R, yes, divided by 2 plus 3. So you are going to get 5R here and 12, which is going to be 17R by 5. 17R by 5. Okay. Nonsense. Why? I wrote N1 plus N2 in the denominator. Okay. It's 2 into 3R by 2 plus 3 into 3R. My bad. I made a mistake. Sorry. 5 and 12, which is going to be 17. 9 and 3, 12. So it is going to be 17 by 12. You just mark which one is going to be closer. You just mark which one is going to be closer. That's it. That's it. Now, so I haven't picked questions, man. There are many questions on this. I haven't picked questions, but there are many questions on the similar model. So don't neglect this gamma equivalent, Cp equivalent, Cv equivalent of the gas mixtures. Don't neglect it. Hurry, man. This is the last part. This is the last part and we will be done, right? But I don't know for what reason they have given second law of thermodynamics, man, when they have removed Carnot's engine. And last year, they haven't given questions on heat engine also. They haven't given questions on heat engine. They haven't given questions on refrigerator. Okay, they have removed Carnot's heat engine, fine. But they haven't given any questions on heat engine also. So without heat engine and refrigerator, there is no point in talking about second law of thermodynamics. Right? So, I will briefly do them, but not in detail. I'll briefly do them. First, I'll talk about the heat engine. Right? See, there will be something called as a working substance, which is going to get heat. Right? And that working substance will make the pistons move inside the, you can say engine or whatever it is. So, from a hot reservoir, it gets heat and this working substance does some work and some heat will be rejected to the sink, and that sink is also going to be called as cold reservoir. Right? So basically, how is the efficiency of this heat engine defined? We will talk about that. I'll take one small example with common sense. Jayanti, how Cp was 4R from here. From there. They said 4 by 3, right? So that means it's going to be 4R. Like 4 by 3 gamma is going to be for which gas? It is going to be for polyatomic gas. That's why, Jayanti. Okay. Now look. I have a small question. When you go to the petrol pump, are you going to pay money for the petrol you are going to buy, or are you going to pay money based on how many kilometers the car is going to move? What I am trying to tell you is, see, we buy petrol. Let's say petrol when converted into heat, let's say it is going to get converted to 100 joules. Out of that 100, some amount of heat is going into atmosphere. Let's say some 20 is going to go. Only 80 is converted into useful work. So basically 100 heat you paid money. For 100 heat you paid. That is petrol. When that petrol got converted to 100 heat, 80 is converted to work, 20 is lost to the surroundings. So what is happening, man? Ultimately only this much is getting converted to your useful thingy, right? Why? Obviously when you are sitting in the car, you want more mileage, right? So if the entire money whatever you have paid is not converted into useful work for you, obviously its efficiency is not 100%. What is the meaning of efficiency 100%? Whatever you have given is 100% converted into whatever you want. You want it to get converted into work done so that the wheels will rotate, so that the car is going to travel some distance. So here, when I talk about efficiency, what is happening? What is the useful thing I am going to get? Whatever the work is going to be done by the working substance will rotate the wheels of the car. So W is what I am getting, but what I paid for Q1 heat into 100 gives you the efficiency of a heat engine. Now look, from conservation of energy, Q1 is equal to W plus Q2, right? So from here W is Q1 minus Q2. So put it over here. Then the efficiency is 1 minus Q2 by Q1, where Q2 is the heat rejected, to the surroundings or sink. Q1 is the heat supplied. So this is what you need to know about a heat engine, right? You need to know about refrigerator also. So what is that refrigerator? Exact reverse of heat engine is refrigerator. So what will happen in a refrigerator is that from cold body, heat will be taken by the working substance. When some work is done on it, it throws it to the surroundings. So exact reverse, you reverse the arrows. See, this is the hot one, right? This gets the heat. When work is done on the working substance, it sucks heat from the cold reservoir. So that's what happens. There will be some compressor kind of thing in the refrigerator, or you can say some pump is going to be there. When you turn on the electricity, that pump is going to do work on the working substance, and the working substance then forcefully draws heat from the cold and throws it to the hot one. So when heat is taken from this, so basically how much our heat is taken from this, that much cold it is going to become. So this is the useful thing. But what we are paying for W. When we turn on the electricity, motor does work on the working substance, then it draws heat from the cold reservoir. When heat is drawn from the cold reservoir, it gets more and more cool. So here we talk in terms of coefficient of performance. Always keep in mind whether it is coefficient of performance or efficiency, what we got by what we supplied. We are getting Q2 drawn out for what we have supplied, W, right? So W is going to be what? W is going to be Q1 minus Q2. So this is coefficient of performance. So now you understood heat engine. Now you understood refrigerator, right? Now I can give you the second law of thermodynamics, which is useful for only questions, but you won't feel it. I'll make you feel it also. I will make you feel the second law of thermodynamics. Don't worry. I'll make you feel that. So the second law of thermodynamics has many forms. That's what the books are going to say. Out of which two statements are very important for us. One is Kelvin-Planck statement. So what this fellow has said, no heat engine, no heat engine can convert entire heat into useful work. That means efficiency of 100% is not possible. There is no such heat engine which can have an efficiency of 100%. This is the statement given by Kelvin Planck. And then there is some Clausius statement. What this fellow has done, said. He spoke about refrigerator indirectly. Not indirectly, directly. See, in refrigerator, what is happening? Heat from the refrigerator is thrown to the surroundings. Right? Heat is taken from the refrigerator and thrown to the surroundings. As a result, refrigerator is losing heat, so it cools. And surroundings get heated. Right? So what the Clausius statement Clausius has said is that, man, heat is going from cold body to the hot body. But in order for that to happen, someone should do work, someone should aid or support that process. Naturally, heat goes from hot body to the cold body. If you are going to be forcing, only then from cold body it goes to the hot body. So, heat can't flow from cold body. Heat can't flow from cold body to hot body without the aid of external agent. Without the aid of external agent. These are the two important statements that have been given. One is about heat engine, one is about refrigerator. Now look, these are two different forms for the second law of thermodynamics. But actually, what is second law of thermodynamics? Man, the second law of thermodynamics is actually going to give you the direction of time. As I said, there are many ways to look at second law of thermodynamics, and all those ways will throw ultimately or will come to a situation where it is directly going to give you the direction of time. For example, if you want to understand, look, I have a string connected to a block. You cut the string, then the block moves down, right? If I am going to give the same amount of energy to the block, what it has lost, because when it is going to go down, it has lost potential energy. So how much ever energy it has lost, if the same amount of energy is given to it, will it on its own go up and connect back to the string? No. So there is a direction of flow to everything. So second law of thermodynamics is actually going to give you the direction, and the direction is nothing but direction of time. So there are a few things which are going to happen in one way. There are going to be few things which are going to happen in one particular way. That's what the second law of thermodynamics is going to talk about. Okay, for example, I'll give you one more. Alright, let us talk about free expansion only. Let us talk about free expansion only. See, in the beginning, okay, we stopped, and in the beginning we have gas and there is nothing in the other side of the room. It's just pure vacuum. So when I remove this, immediately the whole gas immediately goes over there. The whole gas is going to immediately expand into this. Now, man, no matter what you do, will the gas on its own, will the gas, whatever has expanded over there, will it on its own come back to this side? Never going to happen. In fact, this is one best example for irreversible process. This is one best example for irreversible process. And what happens in this free expansion? As there is nothing on this side, so there is no work done by the gas. See, for the gas to do some work, there should be something over here, right? On something, the gas should do work. There is nothing over there. So if I am going to talk about ideal gas, work done by the gas is zero. There is nothing. So in that free expansion, work done by the gas is going to be what? Zero. Right? Now, does it get heat from anywhere? No one is giving heat to it. Delta Q. Then from first law of thermodynamics, delta U is also zero. That means temperature is constant. So in free expansion, temperature will be constant. And work done by the gas will be zero. Delta Q, zero. Delta U, zero. And for your kind information, all these irreversible processes, see, you will know the starting point, you will know the ending point, that's it. From this location to this location, how it has come, you won't have information. Even if you have information, you can't retrace the same path. That's what is meant by an irreversible process. You can't retrace the same path. So, why I am talking about this part is, see, the second law of thermodynamics is going to be related to something called as entropy. Chemistry people talk about it a lot. So, I am not going to discuss too much about it. See, if I am going to talk about the whole world or the whole universe, everything put together, either the entropy, or no, not either the entropy. Entropy is always going to increase. What is entropy? The degree of, or you can say it is a measure of disorderness. Measure of disorderness is what they say. We don't want to dig deep in physics. We don't have entropy coming up. For JEE mains, we don't have it. For JEE advanced, we have it. When it comes, we will talk about it. But yes, if you know the starting point and ending point, and if they are going to talk about change in entropy, if we know the starting point and ending point of a process, and if they are going to talk about change in entropy, see, those 2 points can definitely be connected by some reversible process. If you know the starting point and ending point of an irreversible process, those 2 points can definitely be connected with a reversible process. And for a reversible process, change in entropy is given by dq by t. So if you want the total change in entropy, it is integral dq by t. And one more thing, man. So what is dq from here? dq is t into ds, right? So if you want delta q, it will be integral t ds. Yes, you can get some numerical questions where they are going to be plotting temperature and entropy graph, and they will be asking you to find the heat. Yes, area under T and entropy graph is going to give you heat because integration, right? So even if they are going to talk about some irreversible processes, if you know the starting point and if you know the ending point, join those 2 points with a reversible process. When you join it with a reversible process, You know how to calculate the change in entropy for a reversible process. This is the formula which is going to be valid for reversible process, right? Do the integration, get the delta S, same will be the delta S. For this reversible process as well as for the irreversible process which made the gas start from this state and end with this state. So that's it, man. I personally feel that second law of thermodynamics, you won't even get a single question. Second law of thermodynamics, I don't think they will give you a single question. Reason being, in physics, second law of thermodynamics mostly talks about heat engines and refrigerator, as they removed Carnot. Last year, they haven't asked a single question. So in thermodynamics, if there are going to be questions coming in JEE mains 2025, they are going to be mostly on the first law of thermodynamics. That's it. No other thing. No, no derivation for this. No derivation for this one, Jayanti. And one more thing, as I said, please don't dig too deep into this part. For JEE mains, no man. I don't think there will be a single question coming up. Right? Which you people should focus on, the things which I have done before the second law of thermodynamics. Right? So in detail, heat engine, Carnot engine, entropy, all those things will be discussed once the mains is done. For those who are going to be preparing for JEE Advanced, all of this is there. I just gave you a glimpse of it, some patches of data. I will join all those patches of data after your first mains attempt. For now, signing off. Good night. And this PDF will be shared. Bye-bye. Vijay, I think you said you'll ask me something, right? Sir, can I start now to study? Can I crack NIT? See, Akondi Krishna Veni. Keep one thing in mind. You ask this question to anyone on this planet, they are going to say yes. They are going to say yes. Why? Be positive. So if you start now, can you crack? Yes, you can crack. But one thing, irrespective of whether you are going to crack or not, you should say to yourself that if I don't study, I will not get anyway. Pakka I will not get. Definitely you are going to fail. If I study, there is a chance that you are going to make it. Right? So first you start preparing. Right? Krishnaveni, where are you from? If you are from Andhra and Telangana, if you speak Telugu, then there is a channel called Vedanta Telugu JEE. In that channel, I have made a video on weightage and the chapters which are easy to learn. So you better learn, like you just go through that video, and there I have given list of chapters which are easy to be done. You just focus on completing those chapters first, and then Shanmu, I'm studying 9th and I have this thermodynamics first law only. On 9th level, you don't need this much depth, man. But you have learned something, which is good. Okay, anyone else asking? Krishnaveni, then do you know Vedanta Telugu JEE? Have you heard of that? What about others? Arey Vijay, you said, sir, after mains, will you take any advanced course? Is there any way I can learn from you? Vijay, do you mean paid courses? I don't think I'll be able to take the paid courses because I'm busy enough in YouTube itself, man. Right? But yes, after the mains is done, we will start that advanced, and in advanced, there are some concepts which are extra. Those things will be done. Okay. Ratal Kamal, sir. Teaching very well. Thank you. Thank you. Krishnaveni, what we call, I did it. You can just type in chapter weightage or something like that. You will find it in Telugu by Madhan sir. Physics chapter weightage by Madhan sir. Right? You will get it, Krishnaveni. Sir, for fully constant, I have problem while solving multiple. Can I watch Report Kosam series? Yes, you can watch, Nani. You can watch. close to advanced level, you will be able to deal with them. You can ask me personally if you have any one particular concept as a problem. Actually, I have seen your message, but I didn't reply because I was in class. I was in class. No, not రేపటి కోసం. In రేపటి కోసం, I haven't done. I haven't done high weightages in రేపటి కోసం. In infinity, I said to you, right, Krishnaveni, you better recently some days back I have done it. Some 1 week back or something I have done it, right? So search for the videos, you will find it. Or you better type in. You better type. You just type, okay, high weightage by Madhan sir or high weightage by Karan sir or something like that. If you type, you will get the list. Like there are videos and the PDF is also put below the videos. Vijay, sir, I'm weak in mechanics, sir, especially in LM. Do you have any suggestions? Man, if someone is weak in mechanics, the only way to become strong is to solve more questions. If you want very good questions, which are going to give you a lot of conceptual understanding, Shashibhushan Tiwari, there is a book only for questions. You take that book, and that book is easily available online also. Right? PDF free downloads are available online also. You better download that, and from that you solve questions. You will learn a lot from that. Saranya. Sir, I can't understand units and dimension chapter, but all the chapters are okay, sir. Saranya, it's just your feeling as of now. It's just your feeling as of now, right? Saranya, if you speak Telugu, then on units and dimensions, I have done a video in the Telugu channel. You can follow that. Or in this channel also, I think Shreyas sir would have done it, right? So you spend some more time, solve more questions. Pakka, for sure, it will help you, right? In the beginning, you might find it difficult, but slowly, as you start solving more and more questions, you're going to get habituated. Keep one thing in mind: units and dimensions is easy. Trust me. Rathai Kamal, sir, I'm scoring 155 out of 300 in JEE Advanced. I'm depressed, sir. What to do? I'm weak in physics. Come on, man, 155 out of 300 in JEE Advanced. And you are depressed. 50% you are depressed. No, Harshit Reddy, thermochemistry. You are asking the wrong person, Harshit Reddy. I teach physics. Sir, how many problems we want to solve? Aero Aspire IIT. See, it depends. If you are talking about quality questions, 70-80 questions also will do. But if you are going to be talking about on an average mixture of all the questions, then you have to do around 200 questions per chapter. That will be enough. Sir, how many days need to cover 11th main topics? Man, I think 11th main topics, if you focus for 2 weeks, it's enough. Main topics which are bit scoring and bit easier and all those things. If you are trying to cover except center of mass, RBD and fluid mechanics, in 2 weeks you will be able to cover. Best book for solving questions is going to be, according to me, I love Shashibhushan Tiwari. I love it. I love it to the core. Shashibhushan Tiwari, only problems are going to be there. That book is damn good. Sir, if I am good in JEE main syllabus after January, if I prepare for JEE advanced very sincerely, can I get 200? Pakka Vijay, for sure you will be able to do it. Don't worry. See, Krishnaveni, Cengage is going to be better if, like, see, Cengage has good solid illustrations. So what you people are going to feel is that when you are looking at the question, when you see the solution, you will feel that, okay, you are able to understand everything. That's why Cengage has become so famous, because it has a lot of solved illustrations. As solution is there, you see and you feel that, okay, difficult question, and you are able to understand the question. That gives you a false feeling that you are good with the subject. No. After you see the solution, you should try to do it on your own. If you are doing it on your own, then Cengage is good. Varshit, sir, I am unable to overcome all the PYQs. Don't do all the PYQs. Don't do all the PYQs. Try doing last 10 years. If last 10 years is going to be hectic for you, do last 7 years or 8 years. Man, overall, on an average, per chapter, you do 200 PYQs. That's enough. If it is 10 years, fine. If it is last 5 years only, you are having 200 questions, Then also do only last 5 years. That's enough. Thank you then. Bye bye. Bye bye. Man, do like the video.